Hello and welcome to Stat-Free Six Sigma, the webinar being presented today by Praveen Gupta. My name is Karen Maskell and I am the Minnesota ASQ co-vice chair of programs. So I'm your host today, and I'm going to introduce you to Praveen very quickly. I first met Praveen last year at the at the World Conference for Quality and Improvement, and I was very intrigued with his book that he wrote on Stat-Free Six Sigma, and I thought it would be a great presentation for a lot of people, because I think sometimes with Six Sigma, particularly the idea of statistics can get very overwhelming, and so people stay away from it. And I really like the idea that we could get a lot of value out of Six Sigma without delving into some of the very intensive statistics. And so Praveen had offered to, I approached him and he graciously agreed to present this webinar for us. And he's been working with Six Sigma since the very beginning back at Motorola. And so I think we're going to be in for some really great information today, and I hope that you all enjoy it. And Praveen?
Karen, thank you very much, and thanks to ASQ section of Minnesota for hosting the webinar, and welcome to Stat-Free Six Sigma webinar. As Karen said, that I have been working with Six Sigma for a long time, and my screen is freezing. I don't know why. Okay, so this kind of put my face to the name, so you can see I'm just like one of you guys. You can feel free to ask questions toward the end of the session, I think, as we have allocated some time. And so what I would like to do today is really cover some basic background of Six Sigma, when it was started, show you some old pictures and samples of what we did when we developed the Six Sigma concept, because that was my reason for developing this Stat-Free Six Sigma. You know, 2 years ago, I was doing a Greenbelt training at a non-manufacturing organization, and where every time I used the word statistics, and people just slumped in the chairs more. And I thought I will not see them anymore. They're hiding under the table. So after I finished the class, I thought maybe there has to be a way to teach Six Sigma without too much emphasis on the statistics. And that challenged us to create some new way of communicating the tools and methods for improvement. And we are just so excited that we were able to do that. So in this session, we will look at understanding background of Six Sigma and the distinction between acceptable and excellence performance. After today, if you can learn one thing, that acceptable is a bad performance and excellence is the only way to perform, I think that'll be an accomplishment, besides learning elements of Six Sigma, which consist of intent, methodology, tools, and measurements. And I had to break it down because many of us get bogged down into methodology as end in itself and not realizing the improvement, the benefits of the methodology. And then a stat-free approach to improvement. Here we have developed some rules innovatively. You know, in teaching Six Sigma, people get really scared of hypothesis testing, F-test, chi-square test, t-test, z-test, all these tables. So it's just beautiful to see that how we could drive the improvement without using a lot of these esoteric tools for day-to-day problems. Then significance of measuring sigma level. This is something I pursued, and I have pursued since 2003. It's amazing that the number of companies that implement Six Sigma, none of them knows their sigma level and what is the reason. And one of the reasons I recognized many years ago, there was no standard method for developing sigma level. So you will see a way of calculating corporate sigma level. And then implementation of process thinking. That is everywhere as a quality professionals. We talk about the process thinking, and we really have difficult time deploying process thinking. So we have developed this model called 4P model, and that is critical because in our Six Sigma methodology, the final phase, the control phase, is really more than control. It is more like sustaining the improvement, the gains we have realized, and that requires more than control charts. So we'll see some of the tools. So this is going to show you that in May 86 and March 86, I was working on in Austin, Texas, in Motorola Semiconductor Product Division. And I have no idea of the Six Sigma concept, but my boss would tell me, Praveen, they are doing something beyond Three Sigma. Can you look into what it could be? So I started developing my own something beyond Six Sigma. And this was in the manufacturing of computer chips, silicon memory chips, which would go through 160 process steps. And then we recognized if we would just do 99.9% good, our cumulative theoretical yield would be limited to only 70%. As you can see, in 86, we were happy to move this bar from typical 3 sigma control limits to CPO of 1.33 or 4 sigma limits. And then I moved to Schaumburg, where Billy Smith, the inventor of Six Sigma, who was working on Six Sigma process, and I ended up joining his team, where I helped launch the first 4 projects of Six Sigma when we started deploying at Motorola. And here you see the presentation giving under auspices of Bill Smith, the first success story that really resulted in savings of almost like $500,000 and a lot of surprise savings. So one of the things I learned when practicing Six Sigma, that one, it means a lot of improvement very fast, and secondly, there should be surprises in terms of savings, in terms of improvements, if we have done our job right. And then in 1990, I was part of the team of Motorola University that trained Motorola suppliers all over the world, and this is just a picture of training their 120 suppliers and customers. But actually, Motorola realized that they could not be Six Sigma company with 4 Sigma suppliers. So they really invested in suppliers. They educated them at a very minimal cost, provided 4 basic trainings like design for manufacturability, cycle time reduction, Six Sigma, and process improvement. And here, so the first teams that did very well, and I was part of the teams, they did win like a CEO award. And I think it's very critical. And the reason I'm showing that, not just because I did get the CEO award as part of the process, but recognition of successes and sharing benefits were fundamentals of making Six Sigma successful in first 5 years of Motorola. And I believe that it still is the best deployment of Six Sigma I have seen, where they double the revenue, double the sales, the same number of people, and multiplied profits. And employees gain, they got a lot of benefits, a lot of bonus. I personally had a bonus at one time for 6 months, 44% of salary. So we expect, and I expect that when we are implementing Six Sigma, we are not doing it for incremental improvement, few points here, few points there, but we are doing it for dramatic improvement, visible improvement, so everybody can benefit from it. If everybody cannot benefit from it, then it will be difficult to sustain Six Sigma initiative. And here is Bill Smith. I don't know how many of you have seen his picture before. You know, in those days in 86, as you can see from his algorithm for Six Sigma calculations or Sigma calculations, there were no fancy computers yet. There were like a Tandy 64, a Radio Shack, and Commodore 64. Those were the computers available, and there was no Microsoft operating system. I think it was CP/M. That's precursor to Microsoft's DOS operating system, and Excel worksheets. Just for information, so at least you know who invented Six Sigma. His name is Bill Smith, and he was he has a very good sense of humor, fun-loving person. And so when Bill Smith was working in the quality assurance department, he recognized that whatever the customer failures, the field failures are, they are nothing but escaping internal failures. And for every defect found by the customer, about 10 defects will be caught internally. So if we see 10 internally, you will see still 1 escaping out to the field. And many times companies work on reducing field failures, customer failures, without recognizing they really cannot improve the field PPMs or return rate without focusing on internal defect rate. In order to reduce every defect experienced by the customer, we must eliminate 10 defects by improving the process and product design. And that led to thorough accountability and accounting of internal defects and reduction of those defects. And finally, measure what you value. If you measure customer quality, If you value customer quality, start measuring it. So according to the early documents, and interestingly, I have saved a lot of those documents in my early work in 86, 87, 88 timeframe, where Six Sigma was first used. It was an approach to achieving our goals, and the goals were virtual perfection and be best in class in everything we do. So Six Sigma doesn't mean a statistics. Six Sigma doesn't really means that we just deploy these methodologies, DMAIC and those things. They did not exist in those years. It really means is be virtually perfect. And Bill Smith deliberately used virtually perfect because prior to that, Phil Crosby has used zero defects. And zero defects made people believe that they can't achieve perfection. So it's kind of discouraged them from achieving that. So he made a little bit worse better than, worse than zero defects, so 3.4 ppm. But the ultimate goal really is be the best in class in everything we do. So a Six Sigma perspective that employees must become better in what they do by incorporating basic analytical tools rather than becoming the analysts. So our goal really is that our training should be, we shouldn't become statisticians. We are professionals, we are engineers, we are process owners. Our goal is to learn the Six Sigma methodology, learn the necessary tools, and then become better knowledgeable, more informed, and better expert of our area. So if you pay attention to the body of knowledge and the tools available, about 80% of the tools are non-statistical, while remaining 20% are statistical. And 80% of the debate revolves around 20% of the statistical tools. So we have to put in perspective, our goal really is to learn a significant process improvement methodology, which is for the purpose of business and where it helps business to improve its bottom line. And speaking of the bottom line, I think it helps to understand in positioning Six Sigma in the big picture. So when I was developing this business model, like making sure that business is successful, so we came to the conclusion that first of all, the fundamental strategy for a business should not be to make money. It really should be to sustain profitable growth. And when you sustain profitable growth, then it makes you think in the right direction. And to be successful, you need a business scorecard to have the right behaviors to drive the right kind of priorities. You need Six Sigma or Lean to improve the profit by reducing waste and reducing the cost of poor quality. And then you need innovation to grow. I've received a lot of calls from a lot of people, a lot of companies, where they call, Praveen, we have been asked by our bosses like COO or CEO that after deploying Six Sigma or Lean, how many headcounts have you reduced? That is so it has so devastating impact on employees' morale. That should not be part of the equation. So really the goal is like what Motorola did in its first 5 years, that allowing employees to produce more by reducing waste and working on more value-added aspects of the business. So it is critical to see that Six Sigma's job is to improve the profitability, to improve the bottom line. But without working on growth, companies would be shrinking. And we have seen a lot of examples where they're focused on Lean and Six Sigma and improvement, and they have shrunk. And that's not the right direction for businesses to take. So just to be knowing that you need to put in innovation as part of the equation for driving growth. And looking at this is like a chart first made in 1985, and I was teaching this class at Design for Manufacturability at Motorola, where they showed the example of a company where they have two plants, one producing product like you see in the top picture of this on this slide, where acceptable product within the specifications, and the second plant producing the products, focusing on the target. And when they looked at the customer feedback, they found that the plant that produced acceptable product has a poor quality performance of the product and have more customer complaints versus the plant that was producing on target. But I worked on this and I deployed in a company we called it target-driven manufacturing at the time. And we find that when we produce to target, our cost of production is about 30% less. It's a really bottom line. It reduces the cost of poor quality. And it led me to develop this process excellence model where we would see that how it affects the cost of poor quality. Was recognizing excellence means being on target. And what we have found in many manufacturing operations that they are driven more by specification limits. The way it was supposed to work, that we build to target and ship within limits for economic reasons. But somehow in translation, we have forgotten the target. Now we build the limits and we produce a lot of sloppy product. So recognizing that we don't want to produce acceptable product. I've been teaching now at Illinois Institute of Technology's School of Applied Technology, this business innovation class. And when students do minimal work, acceptable work, they really get C grade. They don't get A grades. And so excellence doesn't mean C grade, it means A grade. And to achieve A grade, we have to do our best, and it takes everything. So we have to be on target to really achieve excellence. So as part of the Six Sigma methodology, we say reducing variation. The intent really is come closer to the target, and finally and ideally producing on target. That's a goal. So excellence means producing on target, and we must take an initiative to define targets for our processes. And there's one thing we can do in our operations, look for the processes where the targets have not been defined versus the processes where the targets have been defined. And you will see this fundamental difference in the performance of those two processes. Now, why we are doing Six Sigma? Six Sigma really means is it should affect the profitability, the cost of poor quality. And as you can see in this table, that as Sigma level improves from 2 to 3 to 4 to 5 to 6, the cost of poor quality goes down. And any reduction in cost of poor quality contributes directly to profitability. So Six Sigma really is not a quality methodology for the sake of quality. It's a business performance improvement methodology. It uses various tools for improving the process, but it's a very comprehensive, very complete methodology to contribute to the company's bottom line by doing things very differently than what we have been doing before. And so we were working in a company where they were losing some money, and we want to help them. They want to deploy Six Sigma. So the CEO asked me to come and introduce Six Sigma to the company management team. And he got the idea of Six Sigma as he was driving from one city to another city to visit a customer. So he had an audio tape of somebody's Six Sigma program. He liked the idea. So I gave a presentation to his management team, and CEO says, let's go do it. Now, in this company, we did not implement Six Sigma very blindly. We just say, let's look at the opportunities first that are taking the profit away, that are eating the profit. And then we work only on those opportunities. And guess what? The company turnaround was complete in 9 months, from 5% to loss to 5% profit. And there's the power of Six Sigma. If it is done right, we can really make money by focusing on the opportunities that are contributing to the loss of profitability. So it is more like creating a value stream map for profit and identifying where are the leaks. And those are the opportunities where we can deploy Six Sigma type comprehensive methodology. The question is, what is a return on investment? I have seen a lot of companies where they have taken the Six Sigma initiative, they have provided extensive training in employees, and no return on investment. If it is done right based on the opportunities, that kind of shows you from 100 people to 500 people to 1,000 people, what kind of money is required and how many projects you need to do. We don't have to do thousands of projects to improve the profitability, to practice Six Sigma. I think the key thing is deploying Six Sigma where it means a lot and it means return on investment. Every project has to be economically viable and should return for the investment that is made in the process improvement. So if you're a small company, if you look at a like 100 people company, if you can do 6 or 8 good Six Sigma projects, that will pay the return on investment. That will produce enough return on investment to be successful, and you can continue the process. So I have heard a lot of companies where they have like 10,000 Six Sigma projects or 15,000 Six Sigma projects, and I'm just saying, how is it possible? And when I asked a question to these people, what is the % success rate of these projects? They were scared to say the number, but I suspect it was 5 to 6% number. So we have to be cautious in deploying Six Sigma. Do it cost effectively, do it smartly, and do it where it means economic benefit for the company. So what is Six Sigma? In the beginning, in 86, 87 timeframe, when we were working with Bill Smith, Six Sigma started as a measure of goodness of product and services. so we can prioritize and work on those products and services with a lower sigma level or the poorer quality. But now, since then, and based on its success, and I can say that Six Sigma, at least in my 30 years of professional careers, is the most comprehensive and profitable Six Sigma methodology for business performance improvement. And that's very nice. So as a result of it, it has become a long-term, forward-thinking strategy to fundamentally change the way of doing business for generating immediate improvement to profitability. And when you have cash, cash is king, you can invest in innovation and facilitate the growth. But we shouldn't forget the growth aspects of it. There are too many examples where companies deployed Six Sigma and they suffered a reduction in sales. So if I have, after deploying Six Sigma for 25 years to pursuing a company, I would start with the sales first. Make sure the sales process is tuned in from the Six Sigma's perspective. That means they are growing the sales and follow the methodology. Interestingly, Bill Gates has presented a business model in 2007 at Consumer Electronics Show. And in his presentation, his first blog was, grow the sales through customer partnerships. First, grow the sales. Sales means business. If no sales, no business. So grow the sales, innovate the solutions, then optimize your processes to deliver them, and work with partners in collaboration rather than an adverse relationship. So Six Sigma definitions, it's an approach to achieve virtual perfection fast and be the best in everything we do. Imagine though at the federal bank FDC level, where they issue 45 billion checks, and even if they're like 0.5% error rate, those 45 billion checks means about more than $40 trillion in transactions. A 5% error, a 0.5% error rate, it means $200 billion deficit, loss of $200 billion. But if you reduce it to the Six Sigma level performance, the loss would reduce from $200 billion to $136 million. That's the difference in going from 3 Sigma to 6 Sigma performance. So here's the challenge, because if we are deploying Six Sigma, we must first learn the meaning of excellence and re-emphasizing what does excellence means, because it is a prerequisite for achieving breakthrough improvement, developing breakthrough solutions, achieving dramatic results, and hopefully generating significant savings so we can all share and benefit from it. One, excellence is all about achieving perfection, and perfection means being on target. Target is defined by the customer, and the customers like minimal inconsistencies. Six Sigma is designed to reduce inconsistencies, and Six Sigma is an approach to achieve excellence fast by learning the cause and effect relationships. So it is no magic. It is not just applying design of experiments and find the answer. I have seen in most cases when people depend on design of experiments, the conclusion is inconclusive. And if you do with understanding that you are learning more about the process through everything we're doing in the Six Sigma methodology, then there is no failure. There is no inconclusive conclusion, because you will always learn something from what you're doing in terms of design of experiments. I have seen many times where people jump to the design of experiments when they hear about the problem. But Junichi Taguchi, you might have heard his name, Dr. Junichi Taguchi, he has said that to a question in a conference, that he spent 80% of his time in designing and understanding the process and experimentation and 20% doing. So versus taking very little time in designing using software tools and all the time in doing the experimentation. So design of experiments is a very expensive option to solving a problem. But we have to first use simple, powerful, commonsensical tools to increase our process knowledge. Ultimately, we must believe that the process problem exists because we do not know something about the process. So to solve a problem, our goal should be how do we know more about the process. So problem solving means gaining more knowledge about the process in order to take care of the problem in the process. In statistical terms, Six Sigma means 3.4 defects per million opportunities, or 3.4 ppm defect level. And in non-statistical terms, Six Sigma means having twice the capability as required by the customer. So for manufacturing and non-manufacturing operations, if people can just remember that Six Sigma means having twice the capability as required by the customers, then customers will most likely always get the product. Now, what are the elements of Six Sigma? Well, Six Sigma has 4 elements. It's intent, methodology, tools, and measurements. In most cases, what I have observed, people ignore the intent. They get to the methodology, get to the tools, and use the measurements. But most likely, spend a lot of time in the methodology and the tools. If we want to maximize the improvement from Six Sigma methodology and teaching the intent, educating and learning the intent of Six Sigma is very fundamental. It helps people align their mindset as to what needs to be done, why it has to be done, and it gets them moving. If intent is missed, then they struggle with the methodology because they don't know what they're trying to accomplish. Just saying we are improving the process is not good enough. So I would like to highlight the intent, as I had in this book cover, that focusing on the intent of Six Sigma methodology, that has such a big dividend in the corporations. So intent really is to achieve quick, dramatic improvement. So achieve a lot of improvement quickly or dramatic improvement quickly. So very critical that we achieve dramatic improvement quickly. Leadership has a responsibility. Here dramatic implies improvement significant enough to generate savings, visible savings. We don't there is some money that means we either pick the project that didn't have enough economic advantage, or we must be doing very, very well.
Praveen, can you hear me? Can anybody hear me? We've lost the audio. Praveen, can you hear me?
So goal really is not.
Praveen, can you hear me? Praveen? Hello?
Show the Now it says audio connection restored. Oh, good. So at least we know it is not us. Where is the screen? I haven't seen screen. Can you see my screen now? Can you hear me okay? Hello?
Yes, I can hear you.
Okay, that's good.
Actually, I said all of that to the people online when I was muted. So we had an audio problem. We're going to back up a couple slides and try to pick it up again, and hopefully that'll work. We were thinking about relogging in. Not sure what exactly happened there, but everybody lost the audio, and Praveen couldn't hear me, and so I called him on the phone, and we've hopefully got this. Yes, we can hear you. We could hear Karen, but not Praveen. Praveen dropped, audio's lost. I can hear you. Okay.
Can everybody hear me now?
Hello? Let's see. Let me see who might be here. Doug, can you hear everybody? Doug, I've unmuted you.
Yes, I can hear you fine.
Can you hear Praveen?
Yes, you came across much better.
Okay. So we're going to just pick it up then, because we'll go back a couple of slides. Hopefully if you can hear, then everybody else can hear as well.
So I will start with elements of Six Sigma. Yeah, this is good.
Initially, Karen, he was real low, so it's much better.
Okay.
Oh, okay. Let's say, yeah, go back to page 23 is what somebody else said. So, and Praveen, they're asking if you can speak a little louder. I think that they're having a little bit of trouble, particularly on the phone dial-in. Particularly on the phone dial-in. Are you there? Oh, now I've muted Praveen too. That's not good. Are you there, Praveen? Okay, don't know what happened. Okay, Praveen, are you still there? We've lost Praveen again. Doug, can you hear me?
I can hear you fine.
But somehow we've lost Praveen again?
Yeah.
Okay. Well, how how is that possible? I don't know. All right, let me call him on the phone. I tell him we lost him again. This is bizarre.
You are, hello, hello? Okay, thank you. One more thing. Let's go for the more. Hello, are we there?
Yes, we can
Hello?
hear you. Yep,
Okay, is it better?
we're back. Mm-hmm.
Okay, thank you. So sorry for technical difficulties. Welcome back. So we were the slide 23, elements of Six Sigma. And when we say elements of Six Sigma, there are 4 elements. Intent, methodology, tools, and measurements. So the intent is to achieve dramatic improvement quickly. And to achieve dramatic improvement, there are aspects of Six Sigma. One is aggressive goal setting, graphical representation of your goals, and then effective quality management review, high executive management expectations, a standardized measurement system, and inspiring leadership. So we really have to create the culture, the expectation, from expectation to feedback, to recognition, to incentives, and to education to really benefit from Six Sigma methodology. But there should be a very clear value proposition of deploying Six Sigma methodology, that how much we would be contributing to bottom line. Just deploying Six Sigma methodology because it's a nice thing to do, is a good tool, the proven tool, you may not get all the benefits of Six Sigma methodology. I think that computer is freezing. Okay. So methodology, of course, we all know DMAIC, D-M-A-I-C. So first it used to be called MAIC, then we realized D is missing. And define is the most important phase of the DMAIC methodology. And here, the benefit depends upon what projects do we work on. So I have been to a lot of places where companies or people are working on projects where the chances of making money is very slim. So here's the project priority index. You can use something like this to prioritize a project. And we recommend that initial value of project priority index is really 4 or better because our data is a little sketchy. And the project priority index is a cost-benefit analysis. Is a ratio of the benefit over the cost and then normalized for probability of success and time to complete the project in years. And we must recognize that Six Sigma is not designed to work on the projects for 1 year, 2 years, or 3 years. It is designed to work on the projects for 3 to 4 months. Can you hear me all okay? Then the Six Sigma methodology, the 5 phases: define, measure, analyze, improve, and control. I think we all understand there are 5 phases, and there are certain tools. So the value of the methodology is really following the methodology, because many times, as a human nature is, we know the problem and we jump to solving the problem quickly without properly defining. You know, one time I was working with a team of very highly qualified directors, including director of quality, in a Six Sigma training. And doesn't matter what I would say, they were already pre-tuned to doing what they were supposed to do, what they thought they knew the answer. So applying the Six Sigma methodology, knowing the answer already, is not going to be helpful. And what happened, the final phase of the methodology, when I asked them, have you done this? And they realized that the correlation of their solution to the problem was less than 10%. They were shocked, and because they haven't taken time to understand the process better. So if you look at the methodology, define, measure, analyze, improve, and control, defines purposes to understand the process better. What's going on? Understand the activities, baseline processes, have customer expectations, clear understanding of customer expectations, and creating the project charter and the goal, what you want to accomplish. The measure phase is the baselining of performance. So the define is baseline of activities, measure is baselining of performance, then analyzing is looking into the root cause, why we are having a problem. Then improve is solving the problem so that we have dramatic improvements. And control is a process of sustaining the gains we have realized. And as a quality professionals, we do know sustaining is not possible only by control charts, but it requires process management. So now there are measurements in Six Sigma methodology. And the common measurements are DPU, defects or errors per unit, DPMO, uh, defects per million opportunities, and sigma levels. Why is it important? First of all, if you pay attention to DPU, it is really a measurement customer cares. It's a product measurement. And customers want zero DPU, close to zero DPU. So our goal should be how do we reduce DPUs very, very quickly. Then DPMO is a DPU measurement normalized for the complexity of the process. And as the process owner, we work with the measurement. And our goal is to reduce the DPMO to 3.4 parts per million, very small numbers. And then sigma level is really an executive measurement to drive the rate of improvement. And this is what the missing piece is, where we don't have the corporate sigma levels. Executives don't know how to drive improvement aggressively and dramatically. And so we don't see the changes and the improvement at the rate and the contribution to the profitability as Six Sigma can deliver to organizations. Karen, can you all hear me?
Yes, yes, we can.
Okay, very good, just very fine.
They
So
are.
the key Six Sigma.
Can you talk up just a little bit louder, though?
Okay, is it better now?
Yeah, I think because on the phone, when the people that are dialed in on the phone, they don't have the same kind of volume control that the computers do. So just
so maybe I
yeah,
can use the computer.
speak a little bit, just a little bit louder.
Is it better now? Is it better? Louder?
I think so.
Okay. So in the 5 phases, we have define, measure, analyze, improve, and control. There are some tools. You know, one time, one of the experts sent me a list of tools, and he listed them like more than 400. I just know that we, as human beings, can learn that many tools to benefit from the methodology. And I keep simplifying and keep reducing the number of tools that are critical to the success of Six Sigma methodology. So in the define phase, tools like Pareto Principle, Process Map, Kano's Model, SciPath, CTQ, and the Project Charter are critical tools to benefit from Six Sigma methodology. In the measure phase, we should look at the cost of quality or the cost of poor quality. We should look at DPU or the defects per units. We should look at DPMOs. We should look at sigma levels. And then we should have some descriptive measure of statistics like averages, standard deviations. In the analyze phase, the most important tool is the root cause analysis, which we knew before even the Six Sigma methodology was used. But one of the challenges with the root cause analysis, as we see in our quality management system, there are so many corrective action requests, CARs, and we have recurring problems. So to supplement the fishbone analysis, one must do 5 whys, an action item to the critical important causes on the fishbone diagram. Use FMEA to anticipate implementation problems. Use a scatter plot as a regression analysis to understand the strength of the relationship between input and output. In the improve phase, you can use various methods, but I recommend to use more like a full factorial experiments and comparative experiments. And somebody may question the wisdom of using full factorial experiments. In my training at Motorola in the 80s and 90s, I learned that we don't do the design of experiments in the very beginning. There's a systematic approach to reducing number of variables and gaining knowledge of the process that contribute to likely the problems. And once you reduce the number of variables to 2 to 3, at that time you can do full factorial experiments. I'm not recommending to do full factorial experiments of 10 variables or 12 variables or 6 variables. That would be almost impossible to do. So, but at the same time, there are many simple tools that can remove the trivial causes from our problem solution that can be used and get to the full factorial. And once we identify the performance and the relationship between the variables and the output, then we can do the validation of the solution using comparative methods. Then control. The control phase, of course, the most important thing is more than control chart is really process thinking or the process management model. So we must really deploy a target-driven process management of the process. Now, just to give you some idea, when the first time it's called OCAP developed by Schuhart, out of control action plan, and that led to PDCA by Deming, that these two methods were developed first to control the product. They were not developed for process management because the process concepts were not there at the time. They were still product based. So to really do the process, if you notice that we do the root cause analysis to fix the problem, we do the variability reduction to improve the consistency, and then so people like Deming and Juran and Taguchi and Ishikawa, they have done some things while working with PDCA to improve the performance. The 4P model, which you will see a few slides down in this presentation, was developed by bringing all 5 gurus and their contribution together to really achieve virtual perfection with rather relative ease, but thorough work at the process level. So coming back to the priority project priority index, I think you can find this on literature on the internet and the books I have published, like a Six Sigma Performance Handbook. But PPI is really a cost-benefit analysis, ratio of the benefit to the cost times probability of success to time to complete. And again, time to complete in my projects, when I train in the classes, I typically try to not to exceed time to complete more than 4 months. So if you do that, 4 months is like 0.33 year, yeah, 1/3 of the year. And so it's almost like a fixed for Six Sigma projects. I think everyone should love this Kanos model to learn customers' requirements, because the solution that is developed to delight customers, internal or external, is likely to be successful. So we must know that there are requirements assumed, spoken, and unspoken in the delight level, and we should try to understand that. Then the statistical thinking, very critical. I would rather have people learn statistical thinking than learn all the statistical tools. Using all the statistical tools without clear understanding of statistical thinking would likely lead to inconclusive outcomes. So what does the statistical thinking means? I think it's very interesting, as some of you might have heard earlier, but it really means our ability to differentiate between random and assignable variation. So when we know there's excessive variation, happens to be random, there is specific action to be taken. When excessive variation is due to assignable cause, then different action has to be taken. And so this leads to approach of reducing, improving process in a non-statistical way. So the statistical thinking requires a clear understanding of the difference between random and assignable variation. As we all know, the random variation occurs due to uncontrolled variables that exist in the process environment, such as fluctuation in temperature or driving time to the office, as an example. And when some event occurs routinely, it is a common event, it is no longer a controlled event. So Deming really called it very well. So the random variation is a common variation, and assignable variation is an exceptional variation. So random variation and assignable variations are the terms given by Shewhart, but Deming explained them in terms of common variation and exceptional variation. So statistical thinking means recognizing when the variation is common and when the variation is exceptional. Because if the common variation is excessive, to reduce it, you have to almost redesign the process. When exceptional variation is excessive, it requires adjusting of the process. And this results into 2 aspects of process improvement. One is by improving the means, and second is by reducing the inconsistencies or variability in the process. So in terms of definitions for DPU or the formulas for DPU, they're simple: defects per unit, which is the ratio of total number of defects observed in a sample versus divided by total number of units verified. And then when you have multiple processes, the benefit of DPU is that it is additive. You can just add the DPUs at all processes. You can call it TDU, total defects per unit. I know that was the terminology used at Motorola. And then do the calculations to analyze and look at sigma level. And then defects per million opportunities. In these opportunities, opportunities are very subjective. Sometimes and manipulatable type term. And I've seen that in companies where to make our sigma level good, we can increase the number of opportunities and improve the sigma level. And that doesn't have any impact on the quality of the process. Our goal really is to reduce the number of opportunities. And so the question is, how do you count opportunities? To really count opportunities, you must look at the inputs in the process. That means they are called items. And activities in the process. That means process steps. So really the opportunities in a process consist of items and activities. Now sometimes items could be very large with very minimal impact. So we define the calculation then opportunities as practical items that have opportunity to make defects. So it is, for example, in a board, in a printed circuit board, or in an item, we have like 10,000 washers used. And those washers may not have a significant impact on the performance of the product. So if I count all 10,000 washers, my sigma level may look very good, but it may not have any impact on the quality. So counting the opportunities that matter, that contribute to improving the performance is what we want to do in counting number of opportunities. So items means parts and supplies and materials used in producing something, and activities is a process. So opportunities, if you want to count opportunities in your process, look at items and activities. Of course, in the analysis phase, fishbone or the root cause analysis is very well understood and very well known by most of us. It's a great tool to list potential causes without questioning any cause. Just list them. Then have a consensus in selecting at least one on each major branch. One material, one method, one machine, and one people, or one information, one approach, one skills, and one equipment. So that way we can always focus on, because we know we cannot work on everything. And secondly, if there's a consensus saying there's a specific cause in any of these branches, that is most likely the cause that would be affecting the performance of the process. And then you look at the solutions after you've done the root cause analysis, that how do you solve a problem? I think we have learned in a systems thinking that never solve a specific problem at the symptom level. So to prevent the solution at the symptom level right away, to curb the urge to solve the problem instantaneously, we must first generalize the problem. Try to take it one level above, look at a little bit higher perspective, see where else could be the similar problem, which different plants, multiple processes. For example, if at a process, a documentation is ineffective, is an old document and people are using old document. So instead of solving that documentation problem, that specific process, we must investigate which of the processes in the company may have the similar problem. So once you define this, so the generic problem would be uncontrolled documents. Then you look at it, what could be the solution for the uncontrolled documents in the company, not at a specific process. And once you have developed a company-wide solution for the uncontrolled documents, then you apply this specific solution for the specific problem. So hopefully that gives you some perspective. That do not solve a problem at the specific problem level. Solve it first, go above generic problem, then develop a generic solution, then deploy a specific solution. So always solve the problem one level above you see it, so that you have bigger impact and better return on investment. Now the question is, what does step-free means, and how do we make it step-free? So here the first thing is focus on the intent, the methodology, simple tools, and the rate of improvement. In Six Sigma, it is not that we improve, because everybody is improving today. What's important is the rate of improvement. I remember when we were doing it in Six Sigma, the rate of improvement was about 68% reduction in defect every year. And the goal is not necessarily that you never can achieve that as a 68%. Imagine if your goal was 68% and you achieve 60% improvement. People would still love 60% improvement. That still generates bonus. But versus setting a goal for 10% and achieving 12% or even 8%. That is very invisible improvement. So goal really for Six Sigma methodology is to create visible process improvement. significant process improvement, significant economic impact, so it can be shared with employees. It cannot be emphasized or overemphasized that our really goal is to save a lot of money and share with people and make this improvement fun for people. People should not have fear because of improvement, they don't get laid off. That's so false and so detrimental to the economy of the company and the country, what we have done in the last many years. Statistical thinking is more important than the statistics itself. And as we have said, statistical thinking applies knowing the state of required change in terms of shift in mean or inconsistency, excessive variation. If shift exists, adjust the process. If inconsistency prevails, redesign the process. And stat-free methodology replaces hypothesis testing and related tests by simple rules. So what are the simple rules? Here they are the simple rules. One, if you are improving the process means adjusting the process for improvement, improving the yield. A simple rule of thumb would be improve it by more than 2 standard deviations in the process. And if you do that, you don't have to spend a lot of time in T&Z. Because we are looking at breakthrough improvement, not splitting hair, whether we really have a statistically significant change or we have a statistically insignificant change. Statistics is not telling very clear outcomes like daylight versus night or black from white. We are looking at statistics in the gray area. But our goal really is to have so much improvement is beyond statistical testing. So if you improve at least 2 times more than standard deviations, you will have significant change, and that's what you're aiming for. Then improving inconsistency is interesting, then how we have simplified F-test and chi-square test. So what we did to really memorize and remember this and to internalize this, we created 4 groupings for the experiments. One is very small, small, medium, and large. Very small experiment means sample size of 3, small means 5, medium means 10, and large means 20. Now, if you're doing F-test with this kind of sample sizes, so what are the F values? Quickly knowing that, and these are inverse of sample size, 20, 10, 5, 3, easy to remember. Understand that the smaller the sample, larger F values will be required. So if sample size is 3, if the ratio of the variance is greater than 20, you have significant change. The same thing with if you have larger sample size, then a smaller ratio is acceptable as a measure of significance. And similarly, in the chi-square test, we use to assess reduction in the variance. That if your sample size is very small, I think we inverted it. Okay, if the sample size is very small, sample size small, medium, large. And so what we are looking for is percent variability reduction. And I'm going to change it on the spot. Actually, somehow it should be 80% reduction, 60% reduction, 40% reduction, and then 20% reduction. So if you have, I apologize. So when you have very small sample size, and to be significant, you want to see 80% reduction in variance. If you have a larger sample size, like 20, you can have, say, 20% reduction. It is still significant. And if you have more than 20 pieces, larger sample sizes, if it is a reduction in variation, it is a reduction in variation. If you remember, the t-test or the t-tables goes from like 29 samples, 29 pieces. So when you have very sample-specific test, there is up to 20 and 22, and then after 22, the incremental change. So it's a good rule of thumb that when you have very small samples, if you're comparing 2 variances, F ratio, the ratio should be larger, and if you have variability reduction assessment, then reduction should be larger. And hope this helps in understanding. It's easy to memorize. The 3, 5, 10, 20 are my sample sizes, and the ratio, the F ratio should be 20, 10, 5, 3s, and then variability reduction is 80%, 60%, 40%, and 20%. Karen, is this understandable? Can you still hear me?
Yes, yes, I can hear you. I can hear you well.
Okay, thank you. Very good. So now, here's the last piece. You know, as I was developing this business scorecard to replace the balanced scorecard, the Six Sigma and the simplified methodology like STAT-free, and the innovation, the breakthrough innovation, which is really very, very powerful tool. But the one thing was missing, and my question was, why all these companies struggling, and why every manufacturing company is struggling? And I did the research quickly and found out that why Ishikawa developed the root cause analysis, why Taguchi mentioned offline quality control, or the building of the target, or the loss function, and the Deming for reducing variability, because the model we were using for managing the process was not addressing those concerns. So I developed this process model. It's called the 4P process model. And the 4P process model is prepare, perform, perfect, and progress. And if you notice, preparation is essential for excellence. And so good homework is required for getting A grade. So preparation. So the question is, what is the preparation, and how do you look at that? I looked at Ishikawa's root cause analysis, the 4 M's. He's going back, feedback analysis, and then finding out what went wrong. And now going forward as a preventive approach, we feed forward. Instead of feedback analysis, feed forward. Instead of doing the root cause analysis, why don't we just make sure that those initial elements that will be considered the root cause analysis are there? So as we say, garbage in, garbage out, quality in, quality out. So if we prepare well, outcome is likely to be successful. And we also recognize poor preparation leads to higher defect rate. Remember this, poor preparation leads to higher defect rate. It's expensive. And then perform well. So Durand focused on performance and project management and excellence in execution. And then Taguchi focused on target or the loss function or achieving the perfection. And the Deming was known for using statistical methods for reducing variability. Output Deming is known, and all of these gurus are known for many things. But I'm looking for these aspects of the process management. And Schuhart developed this whole model of process control, the feedback process. So if you look at this, what I have learned that in most companies, when we are improving the process, we are still not seeing significant reduction in cost of poor quality. Now this model helps us understand how we would do this. If we don't define the target, and if you remember the slide, acceptability versus excellence, that leads to continually marginal performance. If you define the target, it requires less validation and verification. So defining targets reduces the cost of appraisal, and better preparation reduces the cost of failures, internal and external. And now you could see how you could reduce the cost of poor quality. And I have done this experiment in a company's precision manufacturing. On the average, by deploying this, we see about 70% improvement in the performance. It's amazing. It's amazing that we published the article in ASQ magazine, Quality Progress, in 2006, August 2006 or July 2006. The first user of the tool were University of Military Intelligence. And they published and they reported that on a process of training soldiers, they saved about 2,200 person hours by just applying the preparation piece of the process management. So it is really amazing, and I would suggest all of you take a look at this very seriously. Even ISO 9000, they were trying to get value of the system. We are unable to deploy process thinking. And for us, applying the 4P model is really practicing the process thinking. Now it allows us to improve the process better. And process means preparation, means performing, means perfecting, means progressing. So progressing means continually striving towards the target, but we should build to target. We should not build to limits. Building to limits leads to limited capability. Building to target leads to perfection and reducing the cost of poor quality and improving profit. Now, how do you continue the improvement? How do you sustain? Of course, you have to audit Six Sigma implementation, take the correcting those findings, and management review and selling Six Sigma successes. It is very, very critical that we publicize successes. And that's the reason I started writing these papers and the books. When I was an engineer working at Motorola, I saw the significant change when you publish a case study internally. It's much easier for people to use. So one of the questions people ask, what is after Six Sigma? Because everything is a fad, has a lifetime. My conclusion was, it was in 2003, that people have to learn to assess the performance of Six Sigma deployment, which we didn't have. So I developed this Six Sigma business scorecard, and that led to the methodology for developing Sigma level. And then to avoid layoffs and continue the profitable growth, innovation was the next piece. So my further work after 2003 has been on these two areas. So this is a scorecard. Again, you can read in the book as you see on the top of the slide. but they're more detailed. But this is very holistic and very easier to deploy rather than having some large consulting firm helping companies implement this scorecard. You know, a scorecard, the cost of deploying measurement should not be the cost of the process, the more than cost of doing the work. So we have to be very cognizant that measurements cannot be the job. Measurements only a verification of performance and identifying opportunities for improvement. So with this in mind, I developed this 10 measurement because our goal is to reduce number of measurements. And from that measurements, I aggregate to business performance index for CEO, like knowing your body temperature. And as you can see at the bottom, the corporate wellness or business performance index, 67.75%, and that tells you ideally it could be 100%. So you have 33% or 32% opportunity for improvement. And I took that back down further to corporate sigma level. As you can see, the corporate sigma level is 3.44. And as to opportunities for errors, I look at the number of executives because people reporting to CEOs and CEOs are responsible for everything. So they are my opportunities as a model for determining sigma level. And to make sure that it is valid, it is workable, it's predictive, that we correlate the business performance index to profitability. And that's the purpose of Six Sigma. So higher the business performance index, better, more profitable the companies. And then I think in the Six Sigma Forum magazine, I wanted to reduce Six Sigma to, innovation to Six Sigma. And I was shocked that the body of knowledge for Six Sigma Black Belt did not have the word innovation. And I remember when we first deployed Six Sigma at Motorola, innovation was a critical piece. Without innovation, without creativity, you cannot develop breakthrough solutions. So I published this article in Six Sigma Forum magazine in 2005. In 2005, this was published in Six Sigma Forum magazine, introducing the innovation framework for Six Sigma projects. And again, there's a book I have written over years called Business Innovation in the 21st Century. And the purpose really is not to deploy rote and generic methodology versus applied creatively solving the problems. And secondly, you cannot achieve 68%, 70%, 50% improvement without doing things differently. So every single Six Sigma project must require doing something differently in order to realize the benefits and earn the bonus. So here's my additional resources, maybe a little sales pitch if you will. The 3 books I have, the Stat-Free Six Sigma, Six Sigma Business Scorecard, and Business Innovation in the 21st Century. And I have been in quality business. Actually, this is my 25th year as a certified quality engineer. But I have been working on in the quality profession as an opportunity to create value because we have significant leverage in the field of quality that we can work in any area. So we should be looking at contributing to companies' performance wherever we can find the opportunity. And people have loved it, and that has led me to work in different areas to support the quality initiative. You know, it's interesting that, as I said in the agenda and published publication for the webinar, that original 6 steps to Six Sigma. When we were deploying Six Sigma and Motorola in 87 to 92 timeframe, and Six Sigma was officially launched on January 1, 1987. These were the 6 steps everybody learned. Our Six Sigma training was only 1 day. And we learned everything about Six Sigma in 1 day. And then all other tools were available in a cafeteria style. Everything is out there. You have the tools, you have statistics available, all these courses are there, and then everybody can learn whatever they want to learn to solve the problems and create significant gains. So here are the 6 steps. Define your products or services, identify your customers and their critical needs, and identify your needs to do well. See, most important thing is step number 3, which we overlook. That also is a preparation in our 4P model. Map your process for doing the work perfectly. Remove non-value added activities and use error-free methods. We want to make sure that making mistakes difficult. We don't want to design a process these are error prone. We want to make the process, design the process that are immune to errors. And it requires some creativity, it requires some work. And then measure the sigma level and continue to improve the process if the sigma level is less than 6. And then if you look at the stat-free Six Sigma methodology, if you look at the define phase, there is no statistics. In the measure phase, it's mostly descriptive statistics. And I do want you to learn the descriptive statistics like averages and standard deviations. and normal distribution, just very simple. But the key is use it. Don't just learn it, but practice it. When I joined Motorola in 1981, my boss, Kurt Wyman, he was just smart using statistics. And my goal was, if I could use like him, I'll be pretty smart. And the goal is really use statistics to predict a performance. So try to predict everyday little things and verify, see how close you are to prediction. And pretty soon you will have a crystal ball in your hand, and you can just tell what's going on. And then transformed, so in analyze phase, there's some statistics, so we transform them into simple rules. Improvement is more knowledge methods, process, gaining the process improvement and process knowledge, and applying like simple tools like full factorial and comparative experiments. And most of us have done comparative experiment before, but we should recognize we never evaluate the improvement just by the difference. We should always evaluate the difference with respect to built-in inconsistency in the process. And then control. Control is more about process management than control charts. And the control charts a device that can be deployed once the process management is in place. So virtually step-free. What we are saying is that for most part, to benefit from Six Sigma methodology, we don't need to spend a lot of energy learning statistics. And again, we don't want to be a statistician. We want to gain statistical thinking, benefit from statistical thinking and simple statistical tools. And for complicated statistical tools, we can then hire or take help from statisticians, because we will never learn them anyway, because we don't use them every day. So if you notice, what I believe that 80% of the Six Sigma is without statistics and 20% or less is statistics. So we have to balance it and not to be lost in the jargon of statistics. We should remain focused on our process, which we are responsible for, which we own. So to summarize, what I would like to say is the stat-free approach to Six Sigma includes understanding why was Six Sigma developed, what is the distinction between excellence and acceptable, what are the elements of Six Sigma methodology, and if you look at the intent methodology, tools, and measurements, intent is the most important aspects of innovation. If we don't learn the intent, we won't see the benefits. If we learn the intent, and even if we don't use we don't know some of the tools, we can get help. But without intent, you can't see the benefits. The stat-free approach to improvement, again, not to be paralyzed by hypothesis testing or the fear of hypothesis testing or some of those fancy sounding tools. You can keep it simple, as we have explained in the process. And then implementation of process thinking is very critical to maintain the gain. And more importantly, just understanding how the process works in the 4P model. And then significance of measuring sigma level. As we have said, that that basic tenet of Six Sigma is measure what you value. If we value our Six Sigma initiative, we must measure sigma level, but that would make us visible how much we have improved and how much we have not improved. Just give you perspective. To go from current level of performance, which is around 3 or so, to Six Sigma level performance, we have to improve 21,000 times. And that kind of improvement cannot come by itself, but just playing with the methodology. We have to be very focused, very deliberate, and very driven, and very smart, and very collaborative to that kind of gain. So we must measure a sigma level to sustain Six Sigma initiative. Otherwise, I can predict you that in most companies, Six Sigma won't sustain. Here's my work as a fellow quality professional, and I'm happy to be ASQ fellow as well. As you can see, my work has been a lot of it on Six Sigma, in healthcare, in different kinds of areas. And then I have written a lot of books on the process, but I've been focusing on innovation recently to support Six Sigma and Lean initiative, because it hurts to see when companies deploy improvement methodologies and the outcome of improvement is layoffs. This is just pathetic. I think we have to take the initiative, take the charge to bring in innovation methods to grow the business. Only then our quality profession can survive. If we don't grow the business, quality start being considered as cost, and which is people don't like. I was in a company in India, and I talked to CEO. He told me he has eliminated quality departments, and quality has gotten better. So just be aware of that. And that's my presentation, and I think we are open for questions.
We have our first question here. Will you be teaching an innovation class at IIT in 2010?
Yes, we are. And actually, it's a great question. You know, to teach this innovation. So my mission was not to develop just innovation, but develop the science of innovation so it can be taught to people. And so we have developed a semester-long course, which I've been teaching for 8 semesters now, and the students love it. We also have professional level seminars. We have executives, managers, and professionals. And not only that, we want to make it available to people so they can teach in their own community, because it is needed everywhere. So we have train-the-trainer program available for learning this business innovation. And one of the first sessions we have scheduled is March 1 through 5 at IIT Chicago. And if anybody is interested, you can send me an email, gupta@iit.edu, or what you see on the screen. I'll send you the link to sign up or to learn more about the course.
Okay, does anybody else have any questions for Praveen? Thank you, Praveen. I appreciate this very thorough presentation. Thank you very much for agreeing to do this and to share this. If you have any questions, just go ahead and type them into the question box there, and we will get them answered for you.
As you are thinking of questions, we have also launched this called International Journal of Innovation Science. And really our purpose is to collaborate globally and develop the science of innovation so it could be easily available to everybody. There's no magic to it, but it is learnable skill. And I can prove to people mathematically how it is it's a science and it is learnable skill, not just a flash of genius.
We have a question here. Can we get a copy of the presentation? Yes. Praveen has made the slides available in a PDF form that I'll be sending out here shortly. We've also recorded this, so you will have access to the recording once that's available. That'll probably take a couple of days, but you will have access to the recording as well.
Karen?
Yes.
I have a question for you.
Yes?
Would that record be available for me to post on the website as a link?
Sure.
Okay.
Sure. Any other questions? We've got 12:51. We just have a couple of minutes left before 1 o'clock. Going once, going twice. Okay, here we go. We have a question. What tools do you recommend for reducing special cause variation?
Well, special cause variation means assignable cause. And for assignable cause, and actually it's interesting that in Six Sigma education, he says Six Sigma is all about reducing inconsistency in the process. Actually, I have observed that most of the projects are about special causes and adjusting the process. So when you have a special cause of the process, it requires process adjustment. That means adjusting the process mean. And for that tools, you have t-test and z-test in the statistical terms, but we have simplified that. So if you can adjust the process mean more than 2 standard deviation in the right direction, you have made significant improvement.
Okay, we have another question here. What 2 books do you believe would be the best investment?
From my perspective, I would say, I know even the performance handbook is $90, but I would recommend Stat-Free Six Sigma to learn quickly about Six Sigma in the right way, which is like $10 on Amazon. And then I would say Business Innovation of the 21st Century.
This is your opportunity now. Any questions you have?
And all of these books except Innovation Solution, which is in the making right now, even though it has been already a bestseller, are available on Amazon.
Excellent. Well, we don't have any more questions right now.
Then
Going
let
once,
me,
going
let me
twice.
put
Go
it
ahead.
like Karen for this my Business Innovation Conference. That every year I have taken the initiative to hold a Business Innovation Conference at IIT Chicago. So I always welcome participation from companies, from people, if they see the deployment of innovation, that methodology that further the understanding of the innovation science, I would welcome participation. As attendees, as sponsors, exhibitors, or even publish an article in the journal. I edit the journal.
Well, again, Praveen, thank you very much for agreeing to do this webinar. This is only our second one, so clearly we're still working through some of the technical issues, but thank you for being patient with us as we work through that and understand, how to make this better for our members and get some of these tools and principles out, particularly to the geographically distributed members that are unable to make the meetings. So I will go ahead and sign off now, and thank you all for attending. We really appreciate it. I will be sending the slides out, like I said, and also a survey so you can give us your feedback and we can continue to make this a value-added proposition for the members.
Thank you very
Oh,
much,
wait,
everyone.
we have another question here real quick.
Oh, lovely. I love questions.
What about the teamwork and people side of making teams work effectively?
Absolutely. One of the aspects of Six Sigma was setting dramatic goals, aggressive goals, like 50, 60% improvement. And when you set a goal of 60, 70% improvement, it is not possible without collaboration. So, and that's called employee participation. And Mortla is a program called PMP, Participative Management Program, is very, very critical. Number one, to set very aggressive goals, and that forces people to collaborate. And that's the only way you can see dramatic improvement. So teamwork and collaboration. Teamwork for the sake of teamwork is no good, but the collaboration really means, teamwork really means is, and you can see the example on a good basketball team and on the court, how they collaborate, how do they work with each other, being in tune to each other and helping each other, using everybody's strength. So I think collaboration is very critical to achieve breakthrough improvement through Six Sigma methodology. Does it answer the question?
I think so. Well, again, thank you all for attending, and we're going to sign off now. I appreciate all of you attending.
Thank you. What do you think?